introductory session, hence let us further streamline that. Yes, I'm talking about microscopic simulation. However, there's a specific type of microscopic simulation that I will be dealing with, and that is the one called as the agent-based microscopic simulation. And this was already very specific to microscopic. Microscopic, it only says that you're modeling each and every entity and how does it move along with time and the world. Now we'll add AI into that general definition and we'll say it's agent-based. So this agent is an entity which uses sensors to read from the environment and it gets this information and it uses actuators to make changes in the environment, and that's what is agent-based simulation. Now that's where the logarithmic term, again to repeat, comes in. So the sensors will see everything around, and these are not real sensors, we're doing a simulation. So the simulation of the sensors for every agent has a proximity query which comes out to be logarithmic of n, and then you got in the actuators which act over here. Now, an agent could be many different types, and now I'm referring to a standard AI theory. So many of you are deliberative agents. You plan everything in your head. You say, okay, if I do this and then I do that and then I do that, what will happen? You need to go from here to the market, and then you say that, okay, this is the time of the bus. If I catch this bus at this time, I'll be here. Then do I go shopping for medicines first, and then I go to a restaurant to eat something, but then I also have a constraint to catch the bus back, or I catch a taxi which is gonna cost me low, or if I catch a bus I can have an extra dessert on the menu of the hotel. You plan everything up and then you act. So that's what is deliberation. Some of you are reactive agents. So you react. You look at things and you react to that. So you're walking, somebody comes in front, you react and move aside. Somebody comes in front, this time it's your friend, so you don't move aside, you carry your friend along, you react. You look at someone and you neither step aside nor you get along, you punch him. He didn't return you money. So these are reactive agents. On seeing everything, you react. So in the standard course of artificial intelligence, we primarily were into different kinds of deliberative agents. So all the A-star algorithms, if this happens, then that happens, to expect many max, if I do this, and this person does this, and this person does this, and this person does this, to the cooperative searches where you make in collaborative joint plans and then you act in the world. So all that was the artificial intelligence course. This time I'll of course not only take agent based, but all my agents will be reactive in nature. So they look at all the surrounding things, technically using virtual sensors, and they will react on top of it. They'll react on them. Something which you would be expecting. Where is machine learning over here? Nowadays, no course is complete unless you do not utter the word machine learning. They are also learning based reactive agents. So when I say the term reactive agent, normally what happens is that my reactive agent are what is said to be rule-based. It may mean there's a if then else rule. If person is in front, he is your friend, go talk to him. If person is in front, he's not your friend, get aside. If person is your friend and he is someone whom you absolutely hate, then you do that. So it could be the same type of rule-based if then. It could be a mathematical function. So my speed is the position of this person plus position of this person minus my position plus position of my friendship level. It could be a mathematical expression. Even that's a rule. It could be a neural network. It could be a fuzzy logic system. All those are nothing but a general class of rule-based system. Even neural network is a rule. You say this mathematical expression is an encoding of some type of a rule, and your rule is that you are operating by that mathematical expression. Fuzzy logic is another rule. It's a mathematical expression and you observe by it. And in learning-based reactive system, what happens is that these rules which govern me are learned. So I am driven by some kind of rules, and these rules that I am continuously driven by are what is learned, and those rules, they make me change the way that I feel. Let's start off with some classic example of a learning rule-based system. So I'm walking outside my office right here, and suddenly I fall. Why did I fall? Because the road was dug up for repairs. I didn't look at it. Now I've learned a rule. I've learned if I do this type of thing when walking and this type of dug up roads come, I need to be careful. I've corrected myself. So next day I'll not fall down. I'll be careful. That's what I've learned. Reinforcement learning, of course. Now, as another example, what could happen is I was getting late and I started running for my meeting, in your case classes, and suddenly I collided with a person because somebody was running out and I was running in. Both of us did not see each other. That again gives me a correction that that's what you need to do. Again, reinforcement learning. Next time I look for the blind spots, I'll be more careful. So I'm continuously updating my rule base. Sometimes what will happen is that, of course, it's a simulated entity, so somebody will tell you in this type of situation that's what you need to do, that supervised learning covered in a different course. Sometimes I only observe different things as I'm acting. I make a database of unique things that I've seen, and I just ask a buddy, hey buddy, in this type of situation, how should I drive? How should I react? How should I move? That's what's unsupervised. Where the last segment where labels are provided, that happens in every AI system by humans. That doesn't make it supervised. So the learning is you identifying frequent patterns. So getting back, this course I'll be looking at reactive agents which are rule-based. We won't be covering learning, of course. We'll only look at normal rule-based reactive systems. However, what we will be caring about is a model. So a model is nothing but it stores all your past percepts and all your past actions, and it tells you, keeps that into your brain, into your knowledge base. So I give you 100 rupees today. next time when we meet, my behavior will be different. Not that I learned something, but because my sensors cannot see that I gave you 100 rupees in the past, it's there in my brain. Those are what I call as the model-based agents. So, model is anything and everything where you feed all the information and keep it into your head so that you can use it. It gives you more information with time. And then for summarizing, what really will happen is we look at rule-based reactive agents. Yes, sometimes things are not visible, but they are into your knowledge base. You can use that. And sometimes you act stupid. Either somebody tells you that was stupid, or you feel it for yourself. Yes, that was stupid, and you learn that. Our primary intention will be to make in rules which make the agent operate in this world. Now, here we do not have just one entity. Here we do not have just one agent. We have got multiple agents. So, more specifically, we will be looking at a multi-agent simulations. So, all of them have a common environment, and each one of the agents, that's your agent 1, it reads from its own sensors and it acts based on its own actuators. And similarly, you've got agent 2, agent 3, and all the other agents. And of course, as it may appear, it does not make much of a difference in the standard AI theory, whether it be one agent or multiple agents. However, there are a few things that will be of our interest. So, when we talk about multi-agent simulations, first, they differ with respect to a communication. So sometimes the agents have a direct communication with each other, and sometimes they have an indirect communication with each other. If they have a direct communication with each other, that means there is either a Wi-Fi hotspot, all of them are connected to them, or equivalently there are other type of simulation or communication protocols that they can use to exchange information between them, Zigbee or a Bluetooth or all these. If there's an indirect communication between them, they cannot directly talk to each other using formal communication protocols. However, what they can do is that they can look at each other's effects. And in terms of classification, that makes a huge difference. So, direct communication, if I ask two of you to do the first assignments given to you, you have a phone call, you've got emails, so you can say, okay, I'll program this module, you program that module, we'll exchange it. These days there are so many tools, and you communicate with each other and come up with a solution. If I say there is no communication, it's exam time, proctored exams, not the corona period. So the person behind can still have a look at the person in front. That's indirect communication. And then you fix in codes. If I tap 2 times, then you show me question number 2. It's indirect communication. More formally, I say that I'm shifting my office. You need to carry my table, 4 of you. With communication, you will say, okay, keep walking, keep walking, keep walking ahead, you stop, let's turn. Indirect communication, you can still look at each other, see what it's doing, you have common sense to act what you need to do. And that's what we normally classify as based on the communication. Indirect communication is a lot more restrictive. You need to act in the world, but all the information that you need in order to act in the world may not be available. And because that's not available, then you need to do something about it. Then communication, you can just on the common Wi-Fi hotspot put information and that will come in. Now, again going back to the same classification again, so if there is a direct communication, a possibility is all your agents could be centralized and they could make in a common deliberative plan. So what that means is all your agents say, okay, step number one, let us all elect a leader. Elections are coming in this institute. And then you say, you're the Gymkhana, you're the students union, you are the president, you decide for everyone. Everybody will give you whatever information is needed. And this guy says, you do that, you do that, you do that, you do that, because I've worked it in my brain. It's best for all of us. And the individual people, they just say, yes, boss, I'll do it. So, that's again standard things that we discuss in AI, not our interest over here. That's how that happens when you have a direct communication between the entities. We look at indirect communication mostly in this course where we make in reactive agents which look at each other mostly indirectly. Some examples will be direct and they react to them. So that will be our intention.